3 to help people. So we start off with the constant, which is 3.100 times 10 to the 8th. We take that and divide it by wavelength. Wavelength then gives you the frequency. So that's how you get frequency. You take the constant divided by wavelength and gives you frequency. That's not the correct symbol for wavelength. It's that one symbol, but I can't draw it. So, sorry. And to get wavelength, we take the speed of light and we multiply it by frequency, and then oh god, sorry. Then that's how you get wavelength. To get energy, we want to take the equation to get energy, which is 6.63 times 10 to the negative 34. What we want to do for that is put it in parentheses and multiply it times parentheses your frequency. Whatever. And then after that, that gives you your energy. And to solve it into like which photon energy and all that, you multiply it by a number that I don't have memorized. Sorry, kiddos. And I don't have my notes because I gave them to Teresa. So that one you're going to have to figure out on your own. And then for the next one, if we want to get into nanometers, you take nanometers, you take meters, and you multiply it times 1 to the exponent of 9. That gives you nanometers. Wait, divide. And then to get to nanometers, we multiply 1 to the 1 times 10 to the 9th, and that gives you your meters. And then to put it into an actual equation for both, so let's say they want you to solve for nanometers, you would go by and start solving for nanometers by doing that equation, which would be nanometers times x to the 10th to the 9th, and that gives you meters. Then you take the meters, and that equals wavelength, and you put it in that equation of the speed of light, which is the constant. That gives you frequency. And then frequency, what you would do if you're trying to find energy after that for a part B equation, you would take the frequency and multiply it times the equation, which is 6.63 times 10 to the negative 34. And then that gives you your energy. She said she wouldn't go into one that gives us like the smaller amount of photons, but who knows, they might, so I would study on that one just in case, because I'll be studying on that one. And then if we were going to have to do like we did that one time where we had to move it, you would go 1, 2, 1, 2, and then you'd move the decimal, which would be here, over to here. And then when it gets here, you get, that's not supposed to be there. Anyway, so after, we're going to just restart. Scratch that, sorry. So we get this, 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 this. If we move this over here, over here, over here, here, we jumped 5 times. So we get 5.0 times 10 to the -5th power. And then that right there would be our wavelength. Now, for wavelength, what we want to do is we want to put it back into this equation of speed of light, which would be the constant, 3.0 times 10 to the 8th, and then that gives you your frequency. And then we would go about doing the whole energy equation.